All right, let's try a hard puzzle. This is now where I'm going to embarrass myself. um, because I'm just trying to see if this is one of the ones I'm stuck on or not. Let's give it a go, and you can. I'll at least explain my logic, and then someone that's better than me. If I get stuck, someone that's better than me will be able to tell me what I'm getting wrong. Um, so as with the previous video, there are some shapes that you just learn to recognize. So I know that this S shape, they have to go on the ends. There's a couple of ways of explaining why. The easiest one is obviously if I put a star in either of the middle spaces, then it's going to eliminate the whole rest of the shape, and there's nowhere for the second star to go. Um, but there's also you can also explain it with the kind of 2 by 2 region idea. Um, if you try and divide it up into 2 by 2 regions, there's kind of two ways you can do that. If you start with a 2 by 2 region on the left, then there's only one space on the right there for uh, your kind of second 2 by 2 region or smaller. And if you start from the right with a 2 by 2 region, there's only one space on the left there that you can fit a bit of a 2 by 2 region. So that's another way of figuring out that in these S shapes, the stars go on the edges. Um, this is similarly this shape here. If we try and divide it up into 2 by 2 regions, or smaller, we get this configuration. Um, and now anything that is in your kind of 2 by 2 region that's outside of the shape that you're dividing up, um, can't be stars, so you can eliminate it. Because if we try to make this space in that 2 by 2 region outside of the shape a star, it's going to eliminate the rest of the 2 by 2 region. So now now we've got nowhere in that two inside that the 2 by 2 region inside that shape to put the second star, right? So wherever I put a star in this remaining space, there's going to be nowhere to put a second star. So this is kind of why I like to talk about these 2 by 2 regions, because um, it lets you. It's quite like you can get to new logic by just kind of working out. Okay, I'm carving up this space into a 2 by 2 region. Um, what have we got next? Um, okay, yeah. So we've got this kind of irregular shape here. But now we've eliminated these two, we can how can we carve up the remaining space into 2 by 2 regions? If we had these 2 by 2 regions, then we know we're left. We've carved it up like this, so we've managed to carve up the entire remaining space into 2 by 2 or smaller regions. So we know anything in those 2 by 2 regions that is outside of the shape um, uh, cannot be stars. Um, and we got two options for this last bit, right? It could have been like this, or it could have been like this. So as we saw in the last video, anytime you got that 2 by 1 shape, you can eliminate everything from both sides of it. Um, now, if we look again at this shape, we've got when we split this into 2 by 2 regions, we've now got a 2 by 1 region, so we can eliminate uh, uh, the shapes at the bottom. So I'm just going to recolor this so that it's easy to tell where they intersect. We've got 2 by 1 region, so we can eliminate the cells below it. now we can carve this up into these sorts of these two by one, 2 by 2 regions or smaller. That in itself isn't particularly helpful, but knowing this yellow region at the bottom, we have to have a star in one of their cells may come in useful later on. Okay, yeah. So in this row here, the rest of, including the rest of this row, we've got this star here, and then in the green region over here in the same row, again we don't know which of those 2 spaces it's gonna have a star, but we know one of them is going to, so we can eliminate the rest of that row. And now we've reduced what was a 3-cell yellow region into a single possible space for that yellow region, which is then, we've now got 1 space for this green region here and 1 space left for this yellow region here. So we can, and for this green region back here now, so that's bounced back on itself, which is nice. We can eliminate the rest of that column because we've already got 2 stars in that column, which has eliminated that space in the yellow region down there. We've now got, let's just tidy up some of my highlighting quickly. Now in this first column, we've got 1 star here, and there's 1 star somewhere in that green region, so we can eliminate the rest of the column. I don't think this is particularly useful, but this is a nice trick. In column 2, we have 1 star, we've got 1 star here, and then in this region at the top, we know the star's going to be somewhere in that 3x1, right? We've got 1 star to place in a 3x1, so this is different to the 2 stars in a 3x1. If we had to place 2 stars here, we know it would go on the edges. We saw that last time. But there's only 1 star to place in here, so we don't know if that 1 star goes at the top, the bottom, the middle, or the bottom. But if you pay attention to this cell here, wherever we put it, top, middle, or bottom, we can see that all 3 of those options eliminate this cell. They also eliminate it from this cell to the left as well. So the cells either side of the middle get eliminated. Obviously, the one to the left, it was already eliminated, but to generalize it. So whenever you get a 3x1 region there where you got to put 1 star in, you can then eliminate the space to the left and right of the middle of it. So I don't think that was particularly useful in this case. I just wanted to show that technique. Okay, if we look at the penultimate row, we've got if we try and divide we know we've got this 2x1 region on the right, and then a single let's undo that highlighting, a single space to the left here. So whichever one of this in the green region, whichever one we put the star in, it eliminates the other part of the green region as an option to put the second star in. So we know that there has to be a star in the left-hand side. That's where the second star goes. So when you see in a column or a row where you've got 2 empty spaces next to each other and then an empty space somewhere else in the row, you know that single empty space has to have a star in. And now we've got our old friend, the 2x1, so we can eliminate the options either side of it. Now we know in the bottom row, so we know in that this bottom right shape, one star has to go in the green region, so one star has to go somewhere in that yellow region. Right? Again, we don't know yet where, but somewhere in there. We already have a second star in the bottom row, so we know that it can't go in the rest of that row. So we can eliminate that space there. In this big shape here, we've got a 2x1 region and a single space. So again, just like when you have in a row or a column, two options two empty spaces next to each other, and then a single empty space somewhere else. You know, there's got to be a star in that single empty space, because wherever we put the star in the 2x1 region, it eliminates the other one. So the second star has to go in that lone empty space. And when we do that, it bounces back on itself. We can fill in the star from the other region. Again, this pattern's coming up all over the place. Look, got a 2x1, and then a single cell in that shape. So we know there's got to be a star there. And now in the third column, we've got 2 stars, so we know it can't be in the rest of the row. In column 2, we've got a 2x1 region where we've got to put 1 star in, so I like to highlight that. I like to mark up those. Okay, this is a nice technique that I can show off. This is one of the reasons for going through all this hard, walking through a hard one, because this is a technique I really like. Looking rows 1, 2, 3, 4, and 5. So these rows here. Within a actually, there's an easy way to get this, but I'll explain it like this because it leads. If you then, like in other situations, you can apply this logic. Actually, no, it doesn't apply. That's annoying. I got too excited about the possibility of showing off a particular technique, but it actually isn't particularly useful to think about that way. We've already in this, so we'll ignore that and hope it comes up later, although I don't think it will. If we look at this row, we've got 2 stars already, so we can finish off the rest of the row. And then in this row, we've already got 1 star, and then somewhere where we know in one of the 2 spaces there's going to be a star, so we know it's not going to be the rest of that row. Okay, I'm going to try and show you this. I think I found a space to use the technique I was excited about. We've got 2x1, so we should annotate. We should eliminate the rest of the spaces either side. Okay, I think I found a space somewhere to try and demonstrate the technique I was excited to show off. This isn't actually where I would go next in this puzzle. I'd probably look at this column here. This column here. But I want to show you this technique, so I'm going to try it, even though it's probably not the simplest example of this technique. Let's look at the last 2 columns. Okay. We know that within 1 column, we've got to have 2 stars. So it stands to reason that within 2 columns, we've got to have 4 stars. We also know our old friend, the 2x2 region, right? We can only have 1 star in each 2x2 region. So a nice technique is when you look at 2 columns next to each other, or 2 rows next to each other, if you try and split up those 2 columns into the empty spaces and 2 columns into 2x2 or smaller regions, you should find 4. If you can find 4 2x2 or smaller regions, you know that those regions have stars in them. So let's try and look at that, how that works out in this particular case in practice. So we've already got this green region here, right? Which is a 2x2 or smaller. We've got this star here, which is 2x2 or smaller. So we've got, of the 4 2x2 or smaller regions we're looking for, we found 2 of them, so we've got 2 left to find. So the rest of the empty space up here is this 3x2 yellow region that I've just highlighted. So we've got to try and work out how could we divide up a 3x2 region into carve that up into 2x2s, right? So we could do it like this, right? So now we've got at the bottom here a 2x1, this green region at the bottom here, the star, and then this yellow 2x2 region, and then the remaining space we just put a 2x1. So that's one configuration we could have for how we could carve up the last 2 columns into 2x2 regions. The other configuration we could have is we've got the green region at the bottom, that star I've highlighted in green, and then we could have a yellow 2x2 at the top here, and then a 2x1 just below it, right? So we've got those 2 ways of carving up those last 2 columns into 4 2x2 regions. In both cases, right, we in either case we had either a 2x1 at the top of the 3x2 region or a 2x1 at the bottom of the 3x2 region. And if we picked either of those configurations, they both, when we, once you've got a 2x1 region, you can eliminate the cells either side of it. They both eliminate cells out of the middle of that 3x2 block, right? So that, as I said at the top of both of these, you learn patterns, you learn shapes, and that's one that I've learned is a 3x2 region. You can immediately eliminate the, you can immediately put a 2x1 regions on either end of it and eliminate the cells either side of those 2x1 regions. So by trying to carve up the last 2 columns into 2x2 regions and finding 4 of them in there, we've now managed to eliminate these cells I've just highlighted in yellow and say they can't possibly be stars. So that wasn't where I would go next in this particular puzzle, but I just wanted to show off that technique. If we look at where I would go next in this puzzle, I said this column here, we've got that same pattern we've been seeing all over the place. We've got a 2x1 region and then a 1 region on itself here. So we know it must be in that 1 region. And we've got 2x1 regions, so we can cross off the ones either side. Now if we look in that column that we just eliminated some cells from, we've got 1 star here. We need another star. The only place a star can go is at the bottom there. So now we know can't be anywhere else in that yellow region. Oh, this is a shape that another one of those shapes that I just know now off by heart. If we try and put a star in the middle of an L shaped like this, it eliminates all the other possibilities. So we know that can't be a star. And now we've got that same 2x1 and single one its own, so we know it goes in the single, right? So I now know, like instantly, whenever I see an L shape, I know just at the top of the L, the top of the long bit of the L is where a star goes. That's just a shape that I've learned to recognize. In this column here, we've got one star here, and then a 2 by 2 here. So we know it can't be in the rest of that column. In the rest of this column, got one star here. The only other space for a star is at the top, so a star goes there. That eliminates some of our highlighted regions, so we can fill in the rest using the pencil marks. In the penultimate column, we've now got our the 2 stars that we need, so we can mark off the rest of the column as not having stars, which then lets us put a star in the rightmost column. Similarly, top row, we've already got the 2 stars that we need, so we can eliminate the rest of the row, which lets us fill in the remaining 2 stars. And we've done a hard game.